heard many times about the weirdness of the quantum world, but there's one phenomenon that stands far above the rest when it comes to weirdness. Of course, I'm talking about quantum entanglement, or as Einstein called it, spooky action at a distance. Quantum entanglement occurs when a pair of particles such as photons or electrons interact in a way that their quantum states become dependent on each other. A correlation is formed between them. In order to understand quantum entanglement, I first have to tell you what spin is. Electrons have a quantum property known as spin. It is a function of its angular momentum. Electrons can have two spin, a positive spin called spin up or a negative spin called spin down. This being a quantum world, it's not as simple as an object rotating. The electrons aren't actually spinning. It exists in a state of superposition, which means it exists in all possible states at the same time until measured. Before we continue, let's step back for a minute. When electrons become entangled, so does their spin. Remember what I said? A correlation is formed between them. However, they will have opposite spin. So if one pair of the electrons has a spin up, the other pair has what? If you said spin down, then you're absolutely correct. The probability of an electron having a spin up or a spin down can be represented on a wave function. The wave function doesn't tell us where we will find the particle. It tells us the probability of finding it in a particular state or location. Imagine a Joe thief has just been let out of prison, and so he starts stealing again. While they can't pinpoint his exact location, the police can assign probability to where he will strike next. Knowing the kind of property that he targeted in the past, the police can guess there's a higher probability that he'll target the wealthier neighborhood. Now, what if the police manage to catch the thief red-handed? Immediately, the spread out probability distribution collapses to being a single point at one location, not anywhere else. Now, here's where the analogy breaks down. The thief hasn't actually spread himself out across the city. In reality, he was only ever in one place. But the reason the police could not pinpoint his exact location was because of the lack of information and not because of an actual property about him. However, for an electron, when we don't know its position, we can't assume it's in a definite place. It's not because of the lack of information, but because of a fundamental property about quantum objects. Ladies and gentlemen, that's quantum entanglement. Of course, this breaks all kind of physical laws, and there must be many questions. How does information travel faster than the speed of light when the speed of light is the fastest thing in the universe? Doesn't this go against Einstein's theory of relativity? Well, all those answers can be summed up in one mathematical equation. Exactly.